Hello all, my name is Ryan Abdelaziz, responding to the voice thread 3 discussion on managing big data in biotechnology research. I'm specifically creating a peer response to Kelly, who is in my group. So first of all, Kelly, I agree with the argument that big data are only useful when experimental context behind them is preserved. Your example of disease and control samples being processed on different days shows how data volume can amplify a confounded design, in that the pipeline may generate precise estimates, but it still cannot distinguish diagnosis from batch. I really like this point that you made. So that also kind of connected with my previous point about interpretive context in psychiatric research. So molecular measures may be highly standardized, while diagnosis or symptoms were reconstructed from records spanning different institutions. Sorry, I think I got a bit loud. But anyways, I was saying that I was basically kind of referring back to my initial post as well, where measurements can be standardized, but diagnoses or symptoms can be reconstructed from records spanning different institutions, diagnostic areas, screening protocols, etc. So a rigorous pipeline, therefore, has to preserve not only specimen and batch metadata, but also how phenotype itself is defined. That was kind of my sort of point, which I think you kind of agree with here. However, I would refine one statement you made about more data increasing power. I think more independent biological units, such as additional donors, generally would improve your precision and power. Technical replicates and repeated measurements can improve measurement reliability or estimation of change over time. They do not create additional independent experimental units. Treating them as independent would result in a sort of pseudo-replication. I think also big data tends to create a multiplicity problem. So testing thousands of genes or proteins increases the probability of false positive findings, which is why family-wise error or false discovery rate control is necessary. These procedures do not change the biological effect, but they make marginal findings less likely to satisfy the adjusted evidentiary threshold. So I think in the textbook, it's noted that for 10 independent tests at an alpha of 0.05, the probability of at least one type error is approximately 0.40 without correction. So that kind of can create a little bit of issues there with more data generally. I think our positions do converge, however. I think experimental design should determine the experimental unit, batch structure, phenotype definitions, primary outcomes, and multiplicity strategy prior to pipeline being built. Otherwise, big data might provide more analytical opportunities without necessarily producing stronger inference. So if I could offer one question to you, Kelly, do you think a standardized minimum for provenance, experimental units, and pre-specified analysis would improve reproducibility, or would it restrict the flexibility needed across different biotechnology platforms? As always, thank you. It's always a pleasure working in a group with you, and I hope you have a wonderful weekend. Thank you.